So let's start by taking a tour of the night sky. Basically, what we're doing is looking at what astronomy is, and this is the part of science that studies everything in the universe, and basically that refers to everything that exists. So energy, matter, space, celestial objects, and stuff like that. So if we start with the stars, basically what we have here is a big celestial body, lots of hot gases emitting energy, so they give off light. The sun is our star, and if you look at this little tiny speck down here, that little speck is our sun, and that's very tiny compared to some of the other stars that exist in our galaxy. Now these are, again, aren't even the biggest ones, um, but our sun is 3.4 times 10 to the 5 times larger than the mass of the Earth, and that's pretty large. However, in the grand scheme of things, um, this is really quite small. So everything is relative, and that's one of the things that I want you to remember as we go through this unit. So large celestial objects that travel around the stars, that's our planets basically. So if you look here, and this is why Pluto is now not considered a planet. It is so tiny, even in comparison to Earth. And then if you look at Earth in comparison to Jupiter, you can see that we are very, very small. So Mercury, Venus, Earth, and Mars, of course, those are the four terrestrial planets. They have rocky surfaces. And then, of course, you have your gas giants, which are the Jupiter to Neptune planets. And they're mostly made up of gas and liquids and things like that. If you look at our moons, the moons basically go around planets. Mercury and Venus do not have moons. However, Jupiter and Saturn have over 60 each. And ours is fairly small in the grand scheme of things. Galaxies. There are lots of galaxies. We have no idea how many, really. It's just a big collection of gas and dust and stars and planets and everything. And of course, our galaxy is the Milky Way. If we look at the Milky Way galaxy, and we can see right here, Earth is, well, our sun actually is a little tiny, oops, our sun is a little itsy bitsy spot right in here in this area. You wouldn't be able to identify the size of the spot, it's so tiny, and that's the sun. And so it's just on one of the arms of our spiral galaxy. So if you look at just some of the facts there about our galaxy, just let me move that out of the way. Basically, it's 100,000 light years in diameter. Our solar system is on one of those spiral arms, about 26,000 light years from the center of the galaxy. And of course, the sun goes around the center of the galaxy, and that takes about 250 million years to go around once. And that's pretty interesting. Our galaxy is just a part of a galaxy cluster. There's 30 other galaxies that's involved in that group, and scientists have concluded that there's about 400 billion stars in our galaxy alone. So with our sun, our star, of course, we have electromagnetic radiation or waves that travel. Um, Most of them we cannot see: radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. The only one we can see is that visible light, and that's just that little section right there. Everything else we cannot see. Radio waves, of course, being longer, lower energy wavelengths, and then you have those gamma rays, and you can see the wavelengths much faster and much more condensed. One thing that I would like you to do when you have some time, you should be able to Google, find it on YouTube. Just look at Solar Storm 2012. There's a part 1 and part 2. They're not really long, but it would be pretty interesting for you to watch that. Um, Now, if we just look at the structure of the sun, these are some terms that you just have to know. It's just terminology. Basically, you have the core, and that's this section of the sun right here in the center. You have your radiative zone, and that's sort of this part that's, radiating out from that core. You have your connective zone, which is right here. Okay, and you have your photosphere, which is this part right here, and then you have your chromosphere, which is just the outer layer, and the corona. Um, you can see in this one, this is sort of like a solar prominence right here, and I know that's hard to see, but this is basically gases shooting up and energy. This little tiny blue dot here, this is the Earth, just to give you an idea of, a perspective of the size of the Earth next to the sun. We're not that close to the sun, of course. Well, we are fairly close, but anyway. The surface of the sun, of course, it has some sunspots on it, so you can see right here a couple of sunspots, and these are cooler areas. You have these solar flares where you have gases and stuff shooting out in solar prominences, and these are those slower, low energy ejections of gas, and that's just traveling out through the corona. Um, the auroras, once when we get those gas particles, basically what happens is you get solar particles colliding with the matter that's in our atmosphere. And when that happens, we get these really nice fancy light shows going on, which are the auroras. We have the northern lights and the southern lights. Something very interesting to see. Like, these are not filtered, these are not photoshopped. These are the actual colors of the auroras, which are on display on the north and south poles at the same time. Okay. One thing that we are concerned about is the fact that we have these solar winds, and from the solar prominences and solar flares and stuff, and they can affect our cell phone and TV communications. The Earth, which is visualized right here, it's very special. We have this kind of field around us that helps to protect us, which is a good thing because we would burn up really quickly if we didn't. But basically, they do affect the temperature of our atmosphere and the density of it. And it can definitely change the paths of any satellites that we have sent up into outer space for communications and stuff. Um, there was a big, powerful solar storm which happened in 2000, which did disrupt communication, satellites, and stuff like that. It is something that we have to consider because we get a lot of these solar winds and solar storms that can definitely knock out our communication and our satellites, and it's something we take for granted, but it is quite possible that we will lose all of that communication technology at any point in time, really. So anyway, that's it for a general introduction into the celestial objects that exist, and we will be continuing from there.